Hey everybody, this is going to be a screencast presentation of how to solve stoichiometry problems with gases. We will review gases at STP because you did that in the stoichiometry unit. And we will also learn today how you can combine PV equals nRT, the ideal gas law, and stoichiometry to solve problems for gases that are not at STP. We will do several practice problems together. That's exactly what I'm going to do in class. So you just do this, take the PowerPoint that I pointed out, follow along, fill it in as you go. You can pause, you can, fast forward, rewind if you want to rewatch something. And then there will be at the end, there's a worksheet that I gave you for you to practice, on your own. So let's get started. Here's a chemical reaction. And remember, if you're going to do stoichiometry, you need to balance them. So I'm going to start with my metal. I see 2 lithiums over here. So I'm going to put a 2. And let me see, look at my carbon next. There's 1 on each side. And I'm going to look at my hydrogen. There's 2 here, and there's 2 over here, so that's good. And then I'm going to look at my oxygen. 2 here, and then there's 2 here. That's a total of 4 over here on the left. And I have 3 oxygens and 1. That's a total of 4 on the right. So as it works out, with just putting the 2 in front of the LiOH, this is now a balanced chemical reaction. So this one's a review of what we did in the stoichiometry unit. We learned that if you're trying to relate amounts of reactants and products, you should start with the amount that you're given. So we're going to start with 1 gram of LiOH. And if it's not in moles, your first job is to convert that into moles. So if you remember from the stoichiometry unit, you would add up what LiOH weighs. Oxygen 16, hydrogen is 1, so that's 17, plus 7 for the lithium. So 24 grams of lithium hydroxide in a mole of lithium hydroxide. So once you have converted your starting amount to moles, remember the mole to mole ratio. We're trying to find the volume of carbon dioxide. So we know that 2 moles of lithium hydroxide react with 1 mole of carbon dioxide. I'm going to put the lithium hydroxide on the bottom and the carbon dioxide on the top. I do that so that my moles of lithium hydroxide will divide out. My grams have already divided out. And now I've got, if I would take 1 divided by 24 divided by 2, I've got an answer for how many moles of carbon dioxide would be produced by this reaction. Now, that's not what I'm looking for. I'm looking for the volume. And this is at STP. We know, and we use this in the stoichiometry unit, and now we know a little bit more about it, that 1 mole of gas occupies, every once in a while, you're going to see that. Every once in a while, I get a random line that shoots across. But 1 mole of gas occupies 22.4 liters at STP. You can only use this if the conditions are at STP. Moles of CO2 divide out. You plug it in your calculator, and you are going to get another random line. Just have to erase the whole thing. And you are going to get 0.467 liters of CO2. If you had to convert that to milliliters, that would be 467 milliliters. Now that's a review. We did problems like that 2 units ago. You guys were actually very good at stoichiometry. I remember that being a really good unit. But if you take a look at the next slide, you will see that it is pretty much the same question, except now the carbon dioxide and all of these reactants and products, they're not at STP, they're at these conditions. Okay. Now, if that's the case, you're going to start this the same way. You got a gram of lithium hydroxide. So that's 1 gram. We said it was 24 grams in a mole. And that's a G. There are 2 moles of lithium hydroxide for every 1 mole of CO2. And you can stop and get a calculation and know how many moles. And I got to get my eraser because I missed a space. It is 0.02. I'm going off the edge here, so hold on. I'm running out of room. So let me write it down below. The answer is 0.0208 moles of CO2. Now, that's not our final answer, though, because we want the volume of CO2. So what you have to do is now use the gas law. We learned PV equals nRT, and if we solve for V, we will divide both sides by P. Now we've got a pressure. Let's kind of draw a circle around the things we have. We've got pressure right here. We've got temperature right here to plug in there. R is a constant. And we have these moles that we calculated. We can plug those in right there. We have N, R, T, and P. Now, I need to make a little room for myself to write. So I'm going to erase my answer over here. But I'll be putting that in for the moles. Okay? So, all right. So we said the moles are 0.0208 moles. R is 0.0821, and that's liter atmosphere per mole K. Temperature, 15. We have to add 273. So when you add 273, that's going to be 288 Kelvin. Divide all of that by the pressure, 1.25 atmospheres. And you can see that the moles divide out, the atmospheres divide out, the Kelvin divides out, and you're left with an answer in liters. So you plug it all into your calculator, and you get 0.393 liters, and that's supposed to be a 9. 0.393 liters. This is the volume that the same amount of carbon dioxide, same moles, because we started both with a gram of lithium hydroxide, so they make the same number of moles of CO2. At STP, the volume was 0.467. Under these conditions, it's much smaller. And so it is important to be able to do a problem at STP, but it's also important to be able to do a problem under other conditions, because clearly we don't need nearly as big of a container. This gas is going to take up much smaller volume. All right, so let's try some other problems together. This one's already balanced. So this compound, we want to know the mass of the KO2 right here. And we are starting with a volume of the CO2. Here's the problem. I can't convert that volume to moles using 22.4. Why? It's not an STP. I can convert that volume to moles, though, using the gas laws. PV equals nRT, so if I divide both sides by RT, there's that random line, gotta love it. So if I divide both sides by RT, I can get the moles of carbon dioxide. So the pressure, anybody recognize what I need to do with that? Yep, got to put it in atmospheres. So I convert that to atmospheres and I get 1.18. Volume, all right, that's in liters, don't have to do anything. R, 0.0821 liter atmospheres per mole K. Temperature, 35. You recognize what I need to do, right? Add 273. So now I have to multiply the numbers on top and divide by the numbers that are on the bottom. And I got 0.0. I'm going to run off that edge again. Darn it. See if I can fit it in by not writing that initial 0. I got 0.0933. Lines. You can see what it is now. 0.0933 moles, and this is carbon dioxide because that was the volume of the carbon dioxide. This is moles of carbon dioxide. Okay. Once I know how many moles of carbon dioxide and that many moles of the CO2, I can just do some stoichiometry. I start with the moles of carbon dioxide. I don't need step 1 because it's already in moles, so I go right to the mole to mole ratio, which is 4:4. That's easy enough. 4 moles of CO2 reacts with 4 moles of KO2. Now, if this question said find the moles of KO2, I'd be done, but it says find the mass. So I do need another step. I add this up, 16 times 2 plus 39 for the potassium. That gave me 71 grams. So now I got to put this in my calculator, and I find that it is 6.62 grams of the KO2. And that's my answer. Now, did you see how this problem is really different from the one we did on the last page? This problem here, we did the gas law first. We used the gas law right here first to find the moles of gas. And then we did Stoich second. Do you see that? Compare that to the last one. Here we did the Stoich first, and then we did the gas law second. So it just depends on what kind of problem you're doing. Sometimes you got to do the stoichiometry first. Sometimes you got to do the gas law first. If you look at this one, think for a minute, what are you going to do first? Since you are starting with grams of KClO3, and we got to pass this, sorry. You want to do the stoichiometry first and find the moles of oxygen gas. Convert the KClO3 to moles, and then it's 2 to 3. And the answer that you should get when you do that, and you can pause this and work it out, you get 0.00891, and that's moles of oxygen. For some reason, it doesn't want to write. There we go. Now, once you do that, then the second part, okay, you should do the gas law second, okay? Use the moles and get that to find the volume. PV equals nRT. So if you take nRT and you divide by the P, that'll get you the volume. So plug your moles in. Plug in R. Now the pressure has to be converted to atmospheres and the temperature to Kelvin, but then you plug them in right here. And once you plug all of those in, you should get for the volume of the oxygen gas, since this is moles of oxygen that you're putting in, you're going to put the moles right in there. That'll give you the volume of oxygen. And the volume is 0.229 liters of oxygen. So that's the answer you should get in the end. Now, model it after the ones that we did previously, where we did Stoich first and gas law second. And if you cannot get this answer, please see me, and I will gladly help you out. Or see a classmate who did get that answer. Okay? You guessed it. This time, you have to do the gas law first. I'm going to balance it. And we're starting with the volume of the gas. So we got to do the gas law first. So this one is going to be gas law first. Okay? We're using the volume of the gas to find the moles of the gas. Moles will be equal to PV over RT. You've got the pressure and the temperature and the volume. The only thing that you need is to remember what R is. Plug all of that in and you should get for this answer 0.0128 moles of oxygen. Sometimes this thing gets a little funny. There you go. Now, if you did not get that, there is a little crazy line. If you did not get that, okay, make sure everything's in the right units, like your temperatures in Kelvin. Once you have the moles of oxygen, 0.0128 moles, you can just do stoichiometry to get the mass of the H2O2. So you have 0.0128 moles of oxygen. Got your mole to mole ratio, 1 to 2. 1 mole of oxygen, 2 moles of peroxide. That's hydrogen peroxide. If this said find the moles, you're done, but it says find the mass. So you need another step. Got to add it up. And what is it? 34 grams. And I got, when I solved this one, 0.870 grams of the H2O2. Okay? So you've got an example here of gas law first and Stoich second. And you've got examples, if you flip back through, of where you do stoichiometry first and then the gas law second. Once you are done with this presentation and you've kind of gotten the answers, because I didn't work them all out for you, some of them I just talked through here at the end, then you should, once you have all 5 of these problems, you should take the worksheet that I gave you and try the 2 problems on the worksheet that I provided. The answers are on that worksheet so that you'll know when you've done it right. Good luck. See me with questions. Sorry, having trouble getting back to